Multiplying functions, we know how to do that. I think this is where we stopped, was dividing functions.
Yeah.
Now, this is a little trickier. First of all, when you are dividing a polynomial by a polynomial, it's not typically a division problem.
Okay.
In other words, notice this function right here. They give you h of n and j of n. So j of n divided by h of n is clearly n plus 3 divided by 2n minus 1. Well, you can't simplify that. That's the answer.
Okay.
If they ask you to evaluate it at a certain n, well, you can do that. In other words, if n is 1/2, you can plug it in, come up with a number. But in terms of division, it's not always automatic that you're going to be able to simplify it. Now, clearly, if the numerator was, if you could factor a 2 out and cancel that, that's a different story. But in this case, the numerator divided by the denominator, you can't simplify that.
Yeah.
You could evaluate it, but all right, so let's try this one. Here, let me write this up here. So, what is g over h of t? What should I write?
So you should write t squared minus 4 over t plus 8.
Now, can I simplify that?
No. Actually, you could do...
You could try. In other words, we don't know for sure. We could factor the top. What's the top factor into?
It would be, so t times t minus 4?
No, it's t minus 2. What we're looking at here is the difference of perfect squares. So it factors into t minus 2 times t plus 2. Now, that's nice, but it doesn't help. In other words, we still have no way to simplify that. So we could say that's the final answer, or that's the final answer. Either one. I'm going to go with the original. Since there's no way to simplify it, then we'll just put what we had, which is t squared minus 4. In other words, factoring is good, but it doesn't really do any good if it doesn't help simplify it.
Okay.
Okay? And it doesn't in this case. So we're not going to worry about factoring it.
Okay.
In other words, there's no advantage to factoring if it doesn't simplify. If this was t squared minus 64, then it would factor into t minus 8 times t plus 8, and the t plus 8 could cancel with the bottom t plus 8, and it would make a huge difference by factoring.
Okay.
But if it doesn't simplify it, then there's no reason to do it. So that should be the answer. All right. problem 4.
Okay. So
first of all, give me the function. What is P over Q?
P over Q would be 5R minus 2 over R plus 2.
And now tell me what that is evaluated at 4.
So it would be 18 over 6, which would then be 3.
Okay. Now this is a little different. First of all, tell me what f over g of x is.
It would be x plus 4 over x minus 3.
What makes that undefined?
You can't simplify it anymore.
No, that's true. But what makes it undefined? What's a value for x that you cannot ever let x be?
Would it be
The most important rule in all of mathematics is thou shalt not divide by 0.
Yes.
What causes this function to divide by 0? What value of x?
It would be negative 4 or positive 3.
Just positive 3. There is no rule in mathematics that says you can't divide into 0. If x were negative 4, you would have 0 divided by minus 7. That is legitimate. You can do that all day long. It's equal to 0.
Okay.
What you can't do is if x is equal to 3, then you would have 7 divided by 0. This is what is verboten.
Okay.
Always. And I'm not kidding when I say that is the #1 rule in math. Thou shalt not, if you go on to Google and list 10 commandments of math, you'll get 10 different lists. Every single one of them will have this as the first rule. Thou shalt not divide by 0.
Okay.
Remember that. And that's what makes it undefined. Because this is basically infinity. When you divide something by 0, you get an infinite number. So the answer is 3. All right. Now they're giving us word problems. And a lot of people don't like word problems. They have difficulty with them. Understand that a word problem is frequently just an equation. Okay. So, and in most cases, they tell you what the equation is. They tell you distance that this guy runs is equal to minus 0.5 times h, where h is the number of hours that he runs, plus h, 8.5. So that's the distance he runs, d of h. T of h is the number of minutes, which is minus 6 times h plus 90. So you can figure out the distance he runs or the time in minutes that he runs by plugging it into either of these formulas.
Okay.
Well, they're definitely taking this a notch above. Let's talk about distance, time, and rate.
Okay.
This is an important concept in algebra. Let me do this, actually. Hold on a second. What is this function? What is the function that equates distance, time, and speed?
So speed is equal to distance over time.
Let me give you a better way of memorizing that. That is true. R is equal, hold on, sorry. Why? I don't know what that little box there is. It is true that R is equal to distance divided by time. It's just that's not the way you want to remember it.
Okay.
You want to remember that D equals R times T.
Okay.
If I manipulate that algebraically, I get R equals D divided by T. I also get T equals D divided by R. So I can come up with 3 different equations. Well, you don't want to clog up your memory with memorizing 3 different equations. You want to remember one, and one only. Everything else is just a manipulation of that. This is what you want to remember. Distance equals rate, which is velocity.
Yep.
Or speed times time. Why this one? What's an easy way to remember that? Dirt.
Oh, yeah. Okay.
That's why you don't want to remember the alterations of it. They're not easy to remember. If I try to remember R is equal to D divided by T, there's no simple thing to memorize that as. But dirt works perfectly. Just replace the I with an equal sign. And this is all you have to remember is dirt. Nothing else. Okay. So, if we go back to your problem, what did I do? I think, screw this up. Hold on a second. Okay, I accidentally closed this page out. Hold on. Wow, what happened? This was yesterday's stuff. Multiplying and dividing functions. Okay. What's next? Composite functions, it looks like. Okay. Intro to composing functions. Is that where we should go?
Yep.
That's a text file. Oh, actually, I wanted to go back to our previous problem, but I'm not sure I know how to do it, but that's okay. This will work. Notice we have a function. C of A means the amount of corn that's going to be produced, and it's a function of A. That's what C of A means. The amount of corn that's going to be produced is a function of A. What is A? The amount of acres of land that is planted. So if you have 2 acres of land, you got 15,000 minus 1,500, you got that much corn that's going to produce. Okay? 13,500. So M is a different function. It's a function of how much money he's going to make, and it's a function of C, which is how much corn is he going to produce.
Okay.
So if he produces 13,500 kilograms of corn, then you plug in 13,500 to the M function, and you get him $12,100.
Oh, okay.
Now, this includes 2 separate functions, 2 different functions. First function is this one. How much corn does he grow? That depends on how many acres he grows it on. How much money does he make is this function right here. And that depends on how much corn he makes. So there's 2 functions involved.
Okay.
And this diagram is merely trying to show you that if he produces 2 acres of corn, it'll produce 13,500 kilograms of corn, which will make him $12,100 of money.
Okay.
So wouldn't it be great if we could turn this into 1 function instead of 2?
Mm-hmm.
Well, let's try to do that. In other words, if this is the money function, well, I know what C is. C is C of A, right?
Mm-hmm.
So this is a little confusing, but it's not really that hard to follow. In other words, the amount of money I'm going to make as a function of the amount of corn, well, I know the amount of corn is C of A.
Mm-hmm.
A is 7,500A minus 1,500. So if I substitute that for C, I'm going to get how much money I'm going to make based on how many acres of corn I plant.
Mm-hmm.
So I end up with a single function. The amount of money I'm going to make is 6,750 times the acres I plant minus 1,400. By substituting, in other words, you see this step right here where I'm pointing?
Yeah.
Well, if you distribute that 0.9 and then combine the 2 numbers, you get this final function.
Okay.
So that converts the acres planted directly into expected earnings. So now we just have 1 function and we don't need 2. And that's always better. That's simplifying.
Okay.
In other words, if we planted 2 acres, we're going to make $12,000.
Mm-hmm.
12,100. Now, all of this is kind of getting into the subject of composite functions.
Okay.
Notice that what we've done is taking a 2-step process, which is substituting the amount of acres to figure out how much corn we make, and figuring how much corn we make to figure out how much money we make. Well, if we can do that in 1 step, it's better. So we have found a function that takes the number of acres planted and directly converts it to the amount of money we're going to make.
Mm-hmm.
So their notation here is M of C of A. That's how you say that.
Okay.
M of C of A. And notice that is all we do is we substitute C of A into the M function, wherever we see C. All right, enough explanation. Let's try some problems. So,
Hey, Shiloh. 1 sec.
How much money do we make if we plant 1.5 acres?
Let's see. Sorry, I had to mess with my dog. Let's see. We would make.
Tell me what it. You don't need to. I don't care about the answer. Tell me your process.
Okay, so first we want to combine the.
Here's our function right there. You have a single function already.
Yeah. So you want to substitute.
How much money? This is a money function. How much money do we make if we plant 1.5 acres?
We would make. Let's see. So it would be 6,750 times 1.5 minus 1,400.
All right. You have a calculator?
Let me grab one.
You should always have one whenever we're doing a session. Just have one in front of you.
Okay.
Sometimes I want you to use it, but sometimes I don't. But
okay.
On problems like this, I don't expect anybody to do that by hand. It's faster to do it with a calculator, more accurate, better to do it with a calculator. There's some things that it's better to do by hand. Can you hear me okay?
Okay, I got
it. Can you hear me okay?
Yes.
Okay, I just noticed I thought my microphone was off. But, okay, so what's that number?
8,725.
8,725. 8,725. Okay. It's going to be a similar type problem. In other words, the amount of potatoes he's going to make is a function of the acres. Makes a lot of sense. But the amount of money he makes is a function of the amount of potatoes he makes.
Okay.
So what's the composite function here? First of all, let's figure that out. I don't want you to do this in 2 steps. I want you to do it in 1 step. So what is M of P equal?
M of P equals 0.2 P minus 200.
Okay, hold on. What is P?
P is potatoes in kilograms.
What's the function for P?
25,000 A minus 1,000.
Now, notice that our money function, and don't forget the last 1,000.
Yeah.
Can't ignore that. In other words, I substituted for A the potato function, which was 25,000 A minus 1,000. Excuse me, this other number here is 200, not 1,000. Sorry. So there is the money function. In other words, all I did was in place of this P right here, I substituted this P, which is this.
Okay.
That's all I did is the first step. So let's simplify that a little bit. Tell me what that simplifies to.
So that simplifies. So 5,000 A minus 4,800 minus 200.
Well, hold on. I thought you gave me the perfect answer. That times that is 5,000A, right?
Yes.
Also have to do that times that.
Oh, yes. I think I messed up with my calculator.
Which is minus 200. And finally minus this last 200. Which gives us 5,000A minus 400.
Okay.
So that's our M of P function. In other words, the amount of money we're going to make. Notice that it's no longer M of P. I should have written M of A. Because it's not a function of P anymore. This is a function of A, the amount of acres we plant.
Okay.
So, now they give us a specific number. How much money are we going to make if we plant 3 acres?
We will make... We'll make $14,600.
Good. So let's see. Let me figure out what M of A is again. 5,000A minus 400, correct?
Yeah.
And this next question says 5,000A minus 400. So M, the amount of money you make based on the acreage is 5,000A minus 400. Which of the following expressions in other words, we had already answered that.
Okay.
In the previous question. All right. Guess go to lesson page.
I guess, or I think I just saw a next article, so I'm not sure if that would do anything.
Yeah, hold on, let me back up. I thought I saw something also, but well, let's see. Composing functions, I think. We just finished with the intro to composing functions. Let's look at composing functions. All right, this is new. All right. This is hard. Composite, what this really is composite functions.
Okay.
And let me give you some examples, just so you know what we're talking about. I'm not sure they started with the easiest ones. Let's say I have f of x equals x squared plus 1, and I have g of x equals x minus. Yeah, let's make that. And let's make this a minus instead of a plus. Now, if I say to you, what's f of 2?
F of 2 is 4 minus 1.
Okay. What if I said to you, what is f of square root of x?
That would be x minus 1.
Good. So you know that whatever's in the parentheses needs to be substituted for x.
Mm-hmm.
So if I say to you, oops, hold on. If I say to you, what is f of g of x, and that's the way they're always going to present it, then it's really f of x plus 1. What's that?
Okay. F of x plus 1, that would be, so x squared.
Do it
Plus.
Do it in 2 steps. Don't do it in 1 step. That is the way everybody makes mistakes.
Okay.
In other words, the very first step is just substitute x plus 1 for x. Put it in parentheses, square the whole thing, and go from there.
Okay.
Like this.
So x plus 1 squared.
Right. Now simplify it. Because if you do this in your head and then try to subtract 1, you're just heading for mistakes. Okay?
Yeah.
So always just take whatever's in the parentheses, substitute it for x in parentheses, and then simplify. So what is x plus 1 quantity squared equal to?
It would be x squared plus 1.
No. Remember, you got to FOIL it.
Oh, yeah. So it would be...
It's x plus 1 times x plus 1.
Oh, yeah. So then that would be x squared plus x plus 1.
It's actually plus x plus 1 minus 1. In other words, that is what x plus 1 squared is.
Mm-hmm.
So what we end up with is x squared plus 2x. This plus 1 and this minus 1 cancel each other out. So this is what f of g of x is equal to.
Okay.
It's really very simple. Composite functions. Just whatever g of x is equal to, substitute it. In this case, it's x plus 1. And then just do it 1 step at a time. Substitute the x plus 1 for x in the f function. And, and then simplify.
Okay.
Okay? So that, in a nutshell, is the way to handle composite functions.
Okay.
Let's look at some of their problems here. So when we see a problem f of g of 3, we want to work from the inside out. This is a little different. We're not going to take the exact same approach that I just took because they've actually asked us about a specific x. So we always want to work from the inside out. So what is g of 3?
So g of 3 is 3 cubed plus 2.
Which is?
Which is, let's see. $27.
Plus 2.
29.
Okay. So what they're really saying is, what is f of 29, right? In other words, g of 3 is 29. So they're saying, what's f of 29? What's f of 29? If we look at the f function.
Okay, so f of 29 is 86.
Correct. And they go through that logic for you. And here they do what I was showing you. Here in this example, we have two different functions. We have an f function, which is linear, and we have a g function, which is cubic. And they want to know what f of g of x is. So whatever the g of x function is, we're going to plug in. Well, the g of x function is x cubed plus 2. So we're going to plug in x cubed plus 2 wherever we see x.
Okay.
And the f function. Well, the f function is 3x minus 1. So we're going to write 3 and in parentheses x cubed plus 2, because that's the g function, minus 1, and simplify. And we end up with this 3x cubed plus 5.
Okay.
Okay. Yeah, I think these are the same two functions. So what is g of f of 1? Start from the inside out.
Okay. So g of f of 1 is, so it would be 3x minus 1 times x cubed.
First of all, evaluate that. When I say start from the inside out.
Oh, yeah, I see the 1 now.
F of 1 is what?
So f of 1 is 3 minus 1. So that would be 2.
Okay. Now what's g of 2? That's basically what we do here.
G of 2 is, let's see, 8 plus 2, which is 10.
Okay. Notice that none of these are complicated.
Yeah.
As long as you start from the inside out, that's really easy. Once you come up with f of 1, plug it in for the g of x. We're looking at g of 1, or excuse me, g of 2. Yep. And you get 10. So,
okay.
Composite functions are easy as long as you do them step by step. You don't want to get ahead of yourself. It's where you try to do multiple steps at once, and I don't mean you, I mean everybody, where a mistake is made.
Okay.
What is m of n of x? They haven't given us any numbers for x, so we're going to have an answer that is in terms of x.
Okay. So
first of all, what is it? M of what?
m of x is equal to 3x minus 2.
Well, it's
oh, yeah, m of x plus 4.
Okay, so it's really m of x plus 4. That's an important thing to realize.
Yeah.
In other words, all I'm doing is taking the n of x function and substituting. So now I have m of x plus 4, and tell me what m of x plus 4 is. Just substitute. Don't give me a final answer.
So m of x plus 4 is equal to 3 times x, times x plus 4 minus 2.
Okay, now simplify.
So that would be 3x plus 12 minus 2, but it would be 3x plus 10.
All right, that's our final answer. 3x plus 10. This is where people's brain starts to go away. When
Okay.
you start to see notation like fog.
Yeah.
Well, fog means f of g of x. So fog of x means this. We know how to handle f of g of x. If they give us g of x, we're just going to substitute whatever they give us for g of x in for the g of x, and then we'll have f of some other function. And if they give us the f function, we'll be able to proceed.
Yeah.
Let's go down to practice. So, what is g of f of 3?
So that would
step by step.
So
first of all, it's g of f of x.
Mm-hmm.
And now we want to know what is g of 3. Excuse me. G of f of 3.
Yeah.
That's basically the way we're going to solve this problem. So what's the next thing I should write?
So then it would be g of 4.
Good. What's that equal to?
That is equal to f of x, f of 3. Or, oh no, wait, that's equal to
g of 4. This is the problem right here.
Yeah.
In other words, it's simple at every step.
Yeah.
You just have to remember the steps. So what's g of 4?
So g of 4 is equal to -3. Oh wait, no, -5. -5.
Minus 8. Minus 5. All right. Again, they give us two different functions, both functions of t. So tell me what the function is. G of f of t. Notice again, there's no numbers for t. So we're going to get an answer that is in t.
Okay.
So the first thing to write is g of what? What are they asking for? What does that mean?
G of f of t.
Okay. What does that mean? What does g of f of t mean?
G of t minus 2.
What does that mean?
That means, so that would mean t squared.
Do it in one step.
Okay.
Don't do it all at once. Very important. Never do it all at once. It's too hard.
Okay. So g of t squared.
No, we don't have t squared yet. We're going to substitute something for t. What is it?
Oh, yeah. So g of t minus 2 squared.
All in parentheses. And it's not g of, this is the answer. G of t minus 2 is equal to t minus 2 quantity squared plus 5.
Yeah.
So that's what our answer is going to be, only it needs to be simplified. Again, you got to FOIL that. In other words, one of the most common mistakes in algebra is to square this and come up with t squared plus 4.
Yeah.
It's not that. Never is that. There's always a middle term.
So it is t squared minus 2t minus 2.
Multiply that by that. Squared. Multiply that by that. You get minus 2t. Multiply the inside, you get minus another 2t. And if you multiply the outside, you get plus 4. That's t squared minus 4t plus 4. And then we still have the plus 5.
Okay.
Now combine all that. That's going to be our answer. T squared minus 8t plus, oh, hold on, plus 9. That's 4t, sorry. T squared is 4t plus 9. Excuse me 1 second. I'll be back 2 seconds.
Okay.
So let's see, we ended up with t squared minus 4t plus 9, right?
Mm-hmm.
T squared minus 4t plus 9.
Mm-hmm.
Waiting for the check to come up. They're a little slow here.
Yep.
Our website is. What am I doing wrong here? Ah, no? There it is. All right. Now their second, that was what is g of f of t?
Mm-hmm.
What's f of g of t?
F of g of t,
Start from step 1, always.
okay, so it would be f of g of t and that would be f of t squared plus 5. Right up. And then that would be f. Okay,
No,
1 second.
it's not f anymore. In other words, we're giving the function. What is f of t squared plus 5?
That would be t squared plus 5 minus 2.
There you go. So that function is t squared plus 3.
Mm-hmm.
That's going to be the answer. T squared plus 3. Again, I need to wait for their check thing to come up. All right, so here they're going to challenge us with graphs without giving us the function. They're just going to show us the function.
Okay.
F of g of 8. Well, that means this, right?
Yep.
What's g of 8? This is the g function. This one, right?
So g of 8 is would it be like the slope of that graph or
No, these aren't slopes. There's 8.
Okay.
There's g of 8. What's g of 8?
Oh, okay. It would be 2.
Okay, so it's really f of 2. Now let's go to the f function. What's f of 2 equal to?
So f of 2 is equal to 3.
Negative 3.
Negative 3.
Yeah, do not drop the negative signs. You will get it wrong every time. What did I do?
I think you just accidentally highlighted it instead of just clicking on it.
There we go.
There you
go. That's the problem with these things.
Mm-hmm.
They're very tough. They really are. These computer, where you have to answer it, there's so many ways to make a mistake, even if you have the right answer. It's unbelievable. So, all right, let's see. We can go to, should I just click on go to lesson page? Yeah.
Yeah, now there's just a video after that, so.
Let's see. Find composite functions. Did we just do that?
It looks like evaluate composite functions is before that.
I think that's what we just did. Let's try.
Let's
try this one here. Evaluating composite functions. Yeah, we haven't done this. All right, let me bring up my writing tool. So first of all, tell me what h of f of x is in function notation.
So h of f of x is h of 3x minus 5 cubed.
Now we need double parentheses here. If I don't put that second set of parentheses in, it changes the meaning. Okay. So, what is h of that?
So h of that is...
It's a direct substitution.
So 2 times the cube root of 3x minus 5 cubed plus 8.
Let's see, h of f of x, so the plus 8 is outside. So that's the answer, right? Well, not quite. Can you simplify that? What is the cube root of that cubed?
Just 3x minus 5.
So it's really 2 times 3x minus 5 plus 8. Simplify.
That would be 6x minus 10 plus 8, or 6x minus 2.
Does it know when I'm done entering the answer? I wonder if I have to hit enter to bring up that check.
I think there's a blue check one down in the bottom right corner.
Oh, wow. A new system.
Yeah, I think what we were doing was it was like the sheets, and then this one's like quizzing on, I guess, it's supposed to be, I think, quizzing on what you've learned.
They give you another problem to do. Okay. All right. Well, let's finish out our time. We only got a couple of minutes. What is f? Hold on, excuse me. Got to get my writing screen up here. What's f of h of x? What is f of h of x equal to?
So that would be f of x squared minus 6x minus 18.
And what is that equal to?
13 minus x squared minus 6x minus 18.
Now, it's very important that you put the parentheses in here.
Mm-hmm.
If I do not include these parentheses, I get the wrong answer.
Okay.
And the reason is because this is subtraction, every single term is being subtracted. So what does this simplify to?
So negative.
No, just remove the parentheses. What do we get?
So 13 minus x squared minus 6x minus, plus 6x plus 18.
Simplify that.
Let's see. You could then do...
And put it in order.
So negative x squared plus 6x plus 31.
Negative x squared plus 6x plus 31. Negative x, and notice there's no parentheses around that.
Mm-hmm.
Plus 6x plus 31. And that's important that there's no parentheses. If it was negative x in parentheses, that'd be x squared. The fact that there's no parentheses means it's minus x squared. So it makes a huge difference. Where they give you a different, this is total, it's like this was designed by a different programmer. What is g of f of x? Notice here they're using this notation. They're no longer using Goff.
Mm-hmm.
But Goff means this. And og means f of g of x. So just know that they mean the same thing. So what is this?
So this is g of 2x plus 3. Which is x. No, wait, not x.
Tell me the parentheses also.
Okay, so parentheses 2x plus 3 squared minus parentheses 3 times 2x.
It's 3 times. In other words, the 3 goes in front of the parentheses.
Mm-hmm.
And then whatever is in this parentheses goes in for x, so that's the 2x plus 3.
Yep.
Plus 1.
Yeah.
Now, this is harder to simplify.
Mm-hmm.
I'll do it one step at a time. What is 2x plus 3 times 2x plus 3?
So that's 4x squared plus 6x plus 9.
It's plus 6x plus another 6x.
Oh, yeah.
It's always 2 of those. Always.
Okay.
In fact, that's worth learning all on its own.
Mm-hmm.
And I'll get back to that in a second. So this is what we have. Now the rest of it.
And then, so minus 6x plus 9. Plus 10.
No.
Okay.
You have to distribute that negative 3 times plus 3.
Oh, yeah, so minus 9.
Plus 1.
Mm-hmm.
Now I can see that 9 crosses out with that 9. And we end up with 4x squared Let's see, we have a plus 12x minus 6x is plus 6x. Takes care of those two, plus 1. Here's our answer, 4x squared plus 6x plus 1. All right. That's a good place to stop. In fact, I've taken you over a couple of minutes.
Okay.
But just kind of remember where we're at here. We're on practicing finding composite functions. So we'll pick up from there tomorrow night.
Okay. Thank you.
All right. You're welcome. Jonathan, I'll talk to you tomorrow.
Okay.